Okay, everybody, this is 3.1 Inequalities and their graphs. As always, you can visit the Classroom website for answer keys, more videos, review sheets, quizzes, assignments, etc. So they want you to cross out any points that are not solutions of the equation negative 5g equals negative 15. Well, I'm just going to label my points quick. They give us negative 15, they give us negative 5, negative 3, positive 3, 5, and 15. So in order to figure out what the solution of this equation is, we need to solve it. So this is a one-step equation, negative 5g equals negative 15. Remember, between the negative 5 and the g is multiplication, so to undo that, you're going to have to use division. What you do to one side of your equation, you must do to the other. Negative 5's cancel, g equals 3. So they want you to cross out any of the points that are not 3. So go ahead and cross them out. Okay. On the bottom, they want you to write two equations using 3, 13, and k. Well, you can use your imagination here. Let's just do 3k equals 13. And maybe we'll try k over 13 equals 3. Moving on to the definitions, feel free to pause whenever you need. The first definition that we're given is an inequality. So inequalities are mathematical sentences stating that two values are not equal. When you see the word inequality, think unequal. Here's a good representation of unequal. A does not equal B. Okay, so this symbol here means is not equal. So as we learn and go through our chapter on inequalities, we're going to have to memorize and understand these symbols. So we have 4 symbols here. Go ahead and fill those in, and we're going to explain what each one means. The first one says that A is less than B. So whatever the value of A is, it must be less than B. For example, 3 is less than 4. Okay, take your time, fill those in. Well, the next one would be the opposite. That's A is greater than B. For example, 10 is greater than 2. And if you notice, the less than symbol shows up again, but this time it has a line underneath it. That means less than or equal to. So think of it as the less than symbol on top of half of an equal sign. So that could mean two things. That could also mean that 3 is less than 4, or less than or equal to 4. And then it could also mean that 3 is less than or equal to 3. 3 is not less than 3, but it's certainly equal to 3, so that makes that statement true. And the last one is greater than or equal to. Okay. Same deal here. 10 is greater than or equal to 2, and 10 is greater than 2, so that makes the statement true. But it could also work as 10 is greater than or equal to 10. Feel free to pause, make sure you write all this down, and resume the video when you're ready. We're going to use these vocabulary terms, and they give us 5 different mathematical sentences. We need to place them in the correct box, in the inequality box or the equation box. This is pretty straightforward. All you have to do is keep a lookout for your inequalities. So we have greater than, we have less than, we have greater than or equal to, we have less than or equal to. Equations only contain an equal sign. So that should make it pretty easy. Here's my equations. 3x equals 9. And 2 times 4 equals 8. Our inequalities are 17 is greater than or equal to 5. 2x is greater than 5. And 8 is less than 3x. The next portion of this vocabulary terms page asks you to complete each inequality with less than, greater than, less than or equal to, or greater than or equal to. So the statement they're giving us is z is less than 4. And what we want to do is write an equivalent statement starting with the 4 and ending with the z. So all you have to do is flip that entire inequality over. So this becomes 4 is greater than z. G is greater than or equal to -2 means that -2 is less than or equal to g. Notice how you're just flipping the entire statement over. The last one says m is less than 7, so that means 7 is greater than m. Writing inequalities. What is an inequality that represents the verbal expression? It says all real numbers p, and then it gives us two pieces, greater than or equal to 1.5. So we're going to write whether these statements are true or false for 5, 6, or 7. A real number p could be less than 1.5. Well, it says greater here, so that must be false. A real number p could equal 1.5. Well, it does say equal, so that's true. A real number p could be greater than 1.5. Again, it says greater. That is a true statement. The greater than or equal to symbol, you can go back to your definitions if you need, and it's right here on the bottom. So circle the correct symbol, greater than or equal to, choice 4. So complete the inequality that represents the verbal phrase, p must be greater than or equal to 1.5. Identifying solutions of inequalities by evaluating. Consider the numbers -1, 0, 1, and 3. So these numbers, most likely, we're going to have to plug into our inequality. Which are the solutions of 13 minus 7y is less than or equal to 6? Well, solutions means if I plug those highlighted numbers in for the variable y, the equation, or the inequality in this case, will be true. Check whether -1 is a solution of the inequality. So they're taking their first number and we're going to have to plug it in for the value of y. So plug in a -1. 13 minus 7 times -1 is -7. But if you notice there, we have those double negatives that we've been learning about, so we're going to make those pluses. And 13 plus 7 makes 20. Is 20 less than or equal to 6? Well, 20 is greater than 6, so this is false. That does not work. Therefore, the -1 that we plugged in is not a solution. They want us to repeat this process with the next 3 numbers, 0, 1, and 3. So what I'm going to do is I'm going to write the original equation, inequality, in each box, which is 13 minus 7 times a variable is less than or equal to 6. And I'm going to put that in each of the boxes. Now all we have to do is plug in the variables that they gave us, which are 0, 1, and 3. 0, 1, and 3. 13 minus 0 is 13. And 13 is less than or equal to 6. Well, that's false. 13 is greater than 6. So 0 is not a solution. 13 minus 7 times 1, well, 13 minus 7 times 1 is 7. And 13 minus 7 is 6. Is 6 less than or equal to 6? Well, yes, 6 is equal to 6, so that's true. So 1 is a solution, so go ahead and circle 1 for number 13. And 13 minus 7 times 3, well, 7 times 3 is 21. And 13 minus 21 is -8, is less than or equal to 6. Is -8 less than a positive 6? Well, yeah, that's true. So go ahead and circle 3 for number 13 as well. Identifying solutions of inequalities by evaluating. So this is using number lines, okay? And on number lines, if you notice, we have some dots on the number line, and then we have an arrow trending in one of the directions. Okay? So if there is a closed dot, like this one, and like this one, that means the number is part of the solution. If there is an open dot, that means the number is not part of the solution. The endpoint of each graph is -3. Okay, so each of these spots are all -3. Is -3 a solution of the inequality represented by the graph? Explain why or why not. Okay, so the first one for number 14 is not, because it's an open dot. Okay, we don't have to explain each time, just put not a solution. For the second one, though, we have a closed dot, so this is a solution. For 15, again, we have a closed dot. This is a solution. And for the last one, we have an open dot again, not a solution. So here's how we're going to learn how to graph those number lines from the previous question. It says, circle the word that completes the sentence. The solutions of the inequality x is greater than -4 are all numbers, and there we go, we just explained it. This symbol, again, is greater than. Underline the correct word or words to complete each sentence. The graph of x is greater than -4 includes or does not include -4. Well, that's the trick, and copy down these notes here. An open circle is going to be used for greater than and less than. A closed circle is going to be used for greater than or equal to and less than or equal to. That's because you're going to include that point on the graph because it's or equals to. This is the reason. Or equals to. Okay, so in this case, we have just plain old greater than, which means it does not include -4. X is greater than -4 will have an open dot at -4. Okay, so put your open dot right on -4, and all the numbers greater than -4 are to the right of it. So take your arrow and draw it down the line. And put a big arrow on the end. And there's your inequality for number 18 on the number line. Writing an inequality from a graph. What inequality represents the graph? Well, we have an open dot, I see. It's shaded to the left of -3. And the numbers to the left along the orange arrow are less than -3. So again, we have an open dot with numbers that are less than. So that's just the less than symbol. X is less than -3. Choice B. Number 5, it's kind of applying, a real life scenario here to what we're learning today. The inequality S is less than or equal to 8 describes a situation where S is a legal speed. Can the speed be all real numbers less than or equal to 8? Explain. Write stopped, moving, or doesn't make sense to describe each speed. Stopped, moving, or doesn't make sense to describe each speed. Okay, so if you have a speed of 5, that would mean that the car is moving. It's moving on the slower side, but that's okay. And is it possible? Of course it's possible. Cars go 5 miles per hour all the time. A speed of 0. Well, if your car has 0 speed, that means you're stopped. You're not moving at all. Either you're holding the brake or the car is in park. And is that possible? That is definitely possible. But a speed of -3. Now, I don't know about you, but I've never seen a car go negative speed. Some of you may think reverse, but that doesn't mean negative speed. Okay, the car would still be moving at positive speed. So a speed of -3, that just doesn't make sense. That's not possible. So can the speed be all real numbers less than or equal to 8? And the answer is no. Cars cannot have negative speed. Okay. So why don't you give this exit slip a shot? I'll check them when you submit your work.